Hello, everyone. You're getting Carrie at home today. Mondays are my work from home day where I'm usually like focusing on a project or something where I need some like unbroken time and computers with very big monitors. Um, so, Hello, it's sort of like a little impromptu live stream where I am picking up the RBG board, which you see here on your screen. And I did a lot of work on it over the weekend. I ended up not live streaming over the weekend because it was kind of painstaking work. It was like very detailed work, and and I don't mind it. I don't think it's boring or anything, but it's just like finishing up a lot of details and doing very small adjustments that take some time. And I didn't think that it was very good live stream fodder. I thought that you would probably be really bored seeing me tweak her eyes for the 50th time. So yeah, but I am pretty happy with how she's turned out. So I'll kind of go over, I'll give you the rough rundown of what I did over the weekend in much faster time so that hopefully you won't get bored. Oh, also, I am making coffee. I think more coffee. I think, what time is it? Yeah, I think it's time to plunge this and put some more in my cup. I am not a morning person. So anyway, it takes me a bit of coffee to get going. And full disclosure, I was also up pretty late last night working on this board. So, all right. Now, without further ado, we are coffeed. And we are now Ruthed. Let me make her big and me small so you can see what's going on. Okay, so we have Ruth. So the first thing, the most obvious thing, like let's talk about is her eyes. So I had like drawn these like small irises last time, just using like a circular trace essentially. And I wasn't really happy with how it was coming out. I thought that she was zombie looking again. And I think like Bob made the suggestion of like looking at the original photo in order to like basically get her eye placement better. And so I did that, and I'm really glad I did that. Oh, let me see if I still have that. Oh, I think I closed the window with all of the tabs. I might try to find it here real quick, because I do think it's a nice thing, to compare which like Supreme Court photo I was basically going off of for this. Yeah, that one. And let's see if we can open the image. Yeah. Okay. Ooh, that's big. Okay. We have two zoom levels. One is quite big. All right, let's see if we can get a few more things on this screen here. Okay. So this was the original photo. And let's see, I can zoom out. So there you can see that, she's sitting with her collar. She has these like really gorgeous, like they look like jade, maybe cabochon earrings on. And she's looking like more or less straight at the camera. And yeah, so the first thing that I noticed when I was trying to do the eyeballs was that I was like, oh, actually her irises are a lot bigger than I was drawing them. And so just basically, making that whole area bigger helped. And then the other thing that I decided to do is we'll go back to the full-on drawing now, full-on PCB layout now. The other thing that I decided to do is instead of just using a perfectly round trace for her eyes, it was like too perfect and too uncanny valley creepy and just wasn't quite right. Because also, like, you know, her lids are shadowing her eyes a little bit, and which is like, you know, pretty normal. Like you don't generally actually see like the full round iris. So so yeah, I decided to make a polygon out of her irises, and as you might well imagine, that was difficult. So it was, you know, a lot of work zoomed in to about this level. Let's see if I can even, it's interesting trying to select a copper void, a keep out copper region. It's not, there we go. There we go. So it was like creating a polygon like that, which, you know, has a bunch of different points and stuff like that. I found a really cool feature though. I'm sure anybody who's experienced with KiCad already knows about this, but I was really frustrated because I would like draw sort of this rough outline, but then I would feel like I needed to actually have more vertices in the middle in order to sort of get the approximation of a round outline. And I was like, God, I don't want to like redraw this whole thing. But what you can do is you can right click and then you can click this. It says create corner. And so basically that adds a vertex at your midpoint. And that was hugely, hugely helpful in being able to really tweak this and like make it look, I hope, somewhat natural. I've still been looking at this too long, and so I'm like, oh, it's not quite right, but you know what? It's good enough. Like I just need to like stick a fork in it. So there were several things going on, and it's a little bit tricky. So I'll go over this with you with all of the layers. So we have, I'm just going to show you the top layers right now. So you know, we wanted her irises to be free of copper and free of solder mask. So it was just bare circuit board so that the LEDs behind them would diffuse through the circuit board. So therefore, I have to have a copper keep out in her eyeball region so that that area doesn't get filled with copper. And then I also have to have a solder mask keep out essentially on it. So when on the solder mask layer is a negative layer, so any shapes that you draw on the solder mask layer do not show up on the solder mask. So then I had to draw, you know, I had to have a solder mask shape that was about the same shape as the copper keep out, and I have to have both of that on both the top and the bottom layers. The keep out, it was kind of interesting. You can actually, I think we can see in properties here, you can actually yeah, you can actually select that the keep out is active on both top and bottom layers. So that was nice. I didn't have to do like a top layer keep out and a bottom layer keep out, just one for it all. And then, you know, I actually needed there to be a ground pour in the middle on both layers. On the top layer, you can see it's let's see, top layer is red. So top layer, it's not that big of a deal. There's a big old ground pour taking up most of the top layer. So there's an easy way of entering ground there. But I wanted it, you know, I wanted it to definitely be really opaque. And so I wanted that also to be mirrored on the bottom layer. And so now on the bottom layer, you see that we have these areas here that would not be connected to our ground plane. Well, I guess this one would, but yeah, it was a little iffy there. So I ended up putting vias in her eyeballs to really connect those ground planes, and I positioned them. You'll be able to see they'll be tinted, there'll be solder mask over them, they'll more or less be invisible, but you'll still be able to probably see them like a little bit under the solder mask. So so basically I positioned them so that I'm hoping that they look like kind of glints in her eyes to make them look like a little bit more alive. So that's what's going on there. The last thing that you might notice is that the solder mask, you know, the solder mask and the keep out and the copper layer itself are all kind of offset just a little bit here. And I did that at the very end. I like drew all of these shapes and like copied them to different layers and things like that. And then I just offset them a little bit at the very end because I wanted, like, I thought that having like a little bit of a gold glint in her eye again would like give it just a little bit more life and make it look like less zombie dead. And so I want to show you how it looks in the 3D view, which I think I'm pretty happy with. Okay, she still looks a little creepy here. It's, but I think like I think it's about as good as I can get right now with the effort that I'm putting into it. And of course, what you're seeing here is like many, many times actual size. You know, actual size is sort of like more like this. So you'll just barely be able to see those glints. But I feel like that gives her a more natural looking eye, you know, especially at this size, right? Than I had before. Again, when you zoom in, everything kind of looks creepy, but I think I'm pretty happy with that. I'm excited to see how that turns out, you know, on the actual boards. So you can see that, yeah, so we have kind of like 4 different sort of shadows going on here. We have like the solder mask over copper. The dark here is solder mask over just the FR4, just the bare board. Then we have like no solder mask over FR4. So we have like a little bit of a combination of all those things. So, and then of course the LEDs are positioned so that they are going to shine right into that area that is free of solder mask. And I'll show you that on this layer. So here are her eyeballs from the bottom layer. Of course, you're looking at everything like this bottom layer is mirrored from what the board will look like in real life, because you're seeing like an X-ray vision, you know, you're seeing X-ray vision of the board. So you're seeing the bottom layer as viewed straight through the top layer, which is normal in circuit board layout programs because you know you need to be able to see how all of your traces and stuff and pads and or pores and layers all stack up, right? But in real life, what you'll see is, let's go back to our 3D view if I can find it. So in real life, what you'll see is that, which is a mirror image of it. So, oh, very interesting. Huh, I think reloading this, oh, I think I found like a little bug. Interesting. Okay, has to do with 3D bodies. I'll go into that later. So, so yeah, this is what it looks like from the back. And I'm pretty happy with that too. Like everything fits with some descriptive text even. Yeah, it's a little bit cluttered, but it's a small board. Like, that's what happens with small boards. I removed the reference designators, so you don't have like U1, C1, D1. You can't like really identify which is which without having, without referring back to an assembly drawing. But when I put the reference designators on, it was just way too cluttered. And it's not that big of a board, so there aren't that many components. So I feel like it's okay to be able to do that. Hey, Geek Mom Projects, hi from Europe. Oh, yay. I'm so happy that you managed to tune in. Oh, I hope you're having so much fun. Mona Lisa PCB next. Oh, God. That would actually be kind of funny. I'm not a super big fan of the Mona Lisa, but I do feel like she has like a really good sort of dead stare anyway that might translate really well with the circuit board. maybe. So yeah, and I mean, thank you so much for your compliments about the eyes and the level of detail there. I honestly spent way too much time on this. Like it was a stupid amount of time, but like I just was really unhappy with my first attempts at it, and I wanted something to look just like a little bit better. So yeah, I am pretty happy with how it finally turned out, I think. Yeah, so I don't know. I think that's pretty much all about the eyeballs. The other thing that I did was I added bling for her earrings. So added some polygons that are free from solder mask there. And what else did I do? So I did that. So eyes were the main thing. And I also checked some patterns. I added some 3D models for patterns, although I'm actually, KiCad is doing some weird stuff with my libraries because several of these I changed in the library last night and uploaded like 3D models for them, and now they're not showing the 3D model. It's not showing the 3D models for them here. Like this one, the battery holder should have a 3D model. It's showing like the updated footprints that I did, but it's not showing the 3D models that I associated, which is quite strange. So I do have a 3D model for the battery holder, for this connector here, and for the LEDs. I do not have a 3D model for this switch. It's one that I bought directly from Alibaba, so I haven't really found a comparable switch with a US manufacturer or distributor. It's a 4-pole dual throw switch. So anyway, I like messaged them and asked like, hey, by any chance do you have like a 3D model for this, a step file that I could use for layout? We'll see what they say. I'm not expecting that they will, but yeah, might be surprised. So yeah, this is the only one that I don't have a 3D model for. I find that like the 3D model visualization is just so incredibly helpful. It's so incredibly helpful to have this preview of what you'll actually see, because I mean, what I'm working in for layout is this, weird colorized version of things, which is good and you need for layout. Is just super helpful for laying down traces and telling your layers apart and selecting things and all of that stuff. But it's not good for a realistic view. And you tend to see things, especially with the solder mask and like areas that are free of solder mask, areas that are going to be gold versus areas that are like covered, or areas that have paste, components that have paste, components that don't. Some of these things are like optional and going to be hand soldered, so I don't want them to have paste on the pads. So yeah, you can really get a much better idea of all of that with your 3D visualization. So I always try to associate 3D models with all of my parts, which is pretty easy to do these days. DigiKey is awesome because you can just look up on a part on DigiKey, and most of the times the manufacturer will have there will be a link right there to a CAD model. I'm not a super fan of the Snap EDA stuff. I have their models tend to be like low quality. So I actually have better luck just going to like GrabCAD or 3D Content Central. Those are my two go-tos for 3D models of electronics components. Like user sourced basically. So yes, what else? So I did change the battery holder. I'm gonna see right now if I can figure out what is going on with the battery, and I'm gonna take a sip of more coffee. Coffee. Oh, so one thing that I should point out, you'll see right here, we still have this one rat's nest connection line. I've not done a DRC check yet, design rule check. That is, oh, what is going on? Oh no, that's right. Okay, never mind. Those views are supposed to be there. I was like, whoa, are those views in the middle of something? No, they're doing good. Okay, false alarm. But yes, so I have not done a DRC yet, which is a design rules check where it's an automatic thing where it goes over the design rules. It makes sure the clearances are good, that I don't have things shorting out that shouldn't be shorting out, that nothing is not connected that shouldn't be not connected. Ooh, I'm actually seeing one thing right here. These are mounting pads for those switches. And I think, so yeah, I'm using a switch symbol that does not have mounting pads in it. So essentially, there was no opportunity for me to connect those to ground in the schematic. And I do want those connected to ground, not because it matters electrically, but it gives them it gives it a little more beefiness for mounting. So if these have 4 spokes coming from them to the ground plane below, it'll just be you know, they'll just be held down a little bit more, because I mean, you can, you know, this is a small switch and it's going to be actuated by somebody's finger, and you know, it's small enough and these pads are small enough that you could actually totally like rip it off of the board if you tried. And we want to kind of prevent that from happening accidentally as much as we can. If I were super serious about it, I would actually make these connect directly to the ground plane. The ground plane would just pour straight over them without thermals. It does, though, make the reflow process a little because this whole entire area has to heat up to the same, you know, to the same temperature as everything else. So in order for the solder to flow in the reflow process. So what tends to happen is then, you know, you get these areas with small copper areas that flow first, and these might take a while longer. And, you know, is the assembly house going to have kind of like the right solder profile for that? Maybe, maybe not. Anyway, you can end up with your mounting pads not flowed very well, which is then, of course, a problem because it's not soldered to the pad very well. So I feel like a good compromise is to just have these pads connected to ground and have little thermal reliefs, because that's at least 4 more spokes on each one. So I will attempt to do that. I haven't tried to associate a pad to a net in the PCB. So we'll see how that goes. So yeah, so back to this connection here. So basically it's telling me that my VBAT net is not fully routed, right? That there is this little stub here that goes from the battery holder to this pad that is not connected to this entire VBAT net, which, you know, connects my LEDs, my switch, and this pad. Now, we know that that's actually not true. They actually are connected, because once this battery holder is soldered on here, it's a big metal piece that goes over and connects those 2 pads together. So in fact, this is connected. Now, like I'm a little more used to Altium. I don't know, relatively recently in the past few years, there's been, they've added a type of, it's either a type of pad connection or a type of, I think they're maybe 2 different things. There are like component jumper types, and then there are like pad jumper types. But basically what it allows you to do is it allows you to designate those pads as being internally connected inside your component so that they don't have to actually be connected on the PCB. And I did a bunch of searching last night with KiCad, and I found a lot of other people asking the same question. This is also something that comes up relatively often with push button tactile, those little, you know, tactile switches that are 4 legs, because, you know, the bottom 2 legs are actually connected together internally in the component, and so are the top 2 legs. And especially if you're, you know, routing only a 2-layer board, you might actually, you know, want to route another trace in between those pads on your board, and you might actually want to use that part as a jumper. And, you know, it's hard to do that. There are ways of getting around this. It would be awesome if people who work on KiCad, if that was on the list of stuff to do, because that would be super helpful. But in the meantime, there are ways of getting around it. Like I could go back to my schematic and I could, like, you know, label this VBAT1 and this VBAT2, and then, you know, have these 2 separate VBAT nets that, according to my schematic, were like not connected, right? And then this little connection line would go away once I updated my PCB. The other thing I could do is just like route a trace around, because like I could do that. But then I have sort of like this extra sort of loop thing happening, which I don't really like. Doesn't matter for the circuit board probably, but it bugs me. So, you know, for this board, I think I'm just going to ignore this DRC error. I could also put a note on the schematic so that like anybody who, or I could put maybe a note in the in like sort of the non-exported fab notes on the layout. That's probably the best idea, actually, to just say like, hey, you know, DRC will have one error. It's this error. This is why, so that I kind of remember that. Or, you know, if somebody else is working on this board, you know, later, or if somebody takes these board files and wants to do something with them, then they'll know that that's okay, that DRC error is okay. So yeah, there's that. What else did I do? Yeah, that was another thing about sort of the artwork side of this, is that I made sure, you can see that there are sort of a bunch of vias in this area. The ground ones don't totally have to be there, but they are helpful because that's kind of, you know, where ground kind of comes into the board. But these ones do have to be there. They're the LED traces that needed to jump layers in order, you know, in order to avoid crossing. So what I did was I just made sure that like all the vias in this area were underneath solder mask, except for, or were underneath silkscreen. They're underneath both solder mask and silkscreen. So basically we only have her like the little eyeball vias that are exposed that you might be able to see. I also made the diameter of the holes pretty small. I usually try to use like 12 or 13 mil holes because fab houses typically have like a lower limit of 10 mils. And I just try to give them a little room from their lower limits. It just generally makes for more reliable boards, you know. But this time I actually made that 10 mils because I really want those vias to be completely covered by solder mask. And I want the holes to be covered by solder mask, and I want the silk screen to also completely cover the holes as well. In my last version, the holes were a little bit bigger and it didn't, and like you could see them through her face, and that was not nice aesthetically. So this time we're going for a more aesthetic look. This one, I didn't have a lot of options to change the position, and I figured since it was in her ear, it's probably fine. So yeah, you can see those are all the vias in here that are being covered up. Let's see, what else? Yeah, okay, let me quick see what is going on here, if I can figure out what's going on here with the footprints, because let's see, this is where it's nice to be able to like turn layers on and off, because like I feel like, I don't know, for some reason those the 3D models weren't coming through, and I don't quite understand why. So we'll go to properties. I seem to be having like a little bit of trouble with like libraries syncing properly, and I don't know why. So, okay, 3D settings. Is this on the right side? Okay, change that to the correct side. Yeah, it's not finding it, huh? Interesting, and it was on the same computer, so I'll probably have to go in, like figure this out. Oh, weird. Why is my path not showing up? Huh. All right, let me see if I can get this to work. I have a bunch, like I already have a step file like library going basically from all the time that I've been working with Altium. So of course now I have to remember, so it's huge and it's not very well organized, and now I have to remember what the heck it is. Oh, actually, sorry, we're just associating the path. So yes, so libraries, step files, select folder. great. So, hey, now it's there. Okay, weird. Oh, maybe, I wonder if I need to do that like globally, perhaps. But now if we go to the 3D model, haha, oh, interesting. And it also associated the other ones now. Okay, so that's good. I'll figure that out a little bit. I think that there's maybe a global project setting that I'm missing for the 3D model library. And I'm also going to have to get that on the cloud so that I can go back and forth between the office and here and still maintain all of those associations. And that probably means I'm going to have to increase my cloud storage because models are big. So I suppose I could maybe put it up on GitHub too or something. I'll have to think about that. Interested if anybody listens to this and has a good solution for 3D model storage and association and stuff. I haven't actually put KiCad stuff on GitHub yet. So that is still on my to-do list. Okay. So yeah, you can see we have this style of battery holder. Let's see, we have this. This is optional. This will not be assembled on the board. So this is like if you want to actually program stuff and you know, play around with the @tiny, which is right here. That allows you to do that and to just hook up a USB ASP or an ABR ISP Mark II to it. So yeah, you'll solder that on yourself because basically, if you're not programming it, I wanted it to be relatively thin. I didn't want there to be anything sticking up that was higher than that battery holder. So you can see our like dip switches here, like kind of just there too. But that's nice. It'll give it like a little bit of a flat part to sit on. And this switch is about the same height as well. So so yeah, I feel like the board came together pretty well. I can show you, we went over the schematic in a previous live stream, so I can give you the quick rundown of what the components are doing here. So here we have our on-off switch, which connects or disconnects the battery. Red and rainbow, we have our two different, oh, I was actually going to change that to rain, so it said red rain. I don't know, that's just funny. Yeah, so these are the two eye modes, either pulsing red or rainbow fading. These are our two LEDs, which are shining through this part of the board, right there. This is the actual processor that's controlling the whole thing. The dot marks pin 1. This here is our red, green, blue LED, like control circuitry. So each red, green, and blue, these are just normal RGB LEDs. They're not addressable. They don't have anything built into them. So each color channel here is turned on and off by a MOSFET here. And those are either connected or disconnected from the processor. And the reason I did that was because I also wanted you to be able to use this as an @tiny board, as a dev board, to do your own circuits. So if you disconnect this whole, you know, actual RGB circuit, what you can do is you can solder a header onto here, just, you know, a regular straight pin header, just like kind of surface mount it. You can stick it into a breadboard, and you can program then through this connector this @tiny yourself, and you can put some sort of auxiliary circuit on your breadboard. This switch has, you know, two positions, either run or program. What that does is it isolates your signals even more. So it isolates all of the signals that are required to program the @tiny. It just puts them straight to this programming connector and disconnects them from these and from those, so that while you're programming, you don't have external circuitry interfering with those lines. Because on, you know, your @tiny, it's so tiny that you have to multi-purpose pins. You have to use pins for both programming and external circuitry. And a lot of times, if you have external circuitry hanging off of those pins, you have capacitors or LEDs or something that's like going to pull a lot of current, then it won't program well because it can't actually get to the voltages required or achieve the speed required for proper data transfer. So what this allows you to do is put it in programming mode. All of those signals go straight out to this connector, and you're pretty much assured of like good data transfer. This is a little LED here, and I actually I want to make it a blue LED that has like a pretty good voltage, forward voltage drop, like 3 or 3.1 or something, because essentially I want it to only light up if you are giving it 5 volts, which the @tiny actually needs in order to program. So while the @tiny 4, 5, 9, 10, they can run off of lower voltage all the way down to 1.8, they can only be programmed at 5 volts. So this LED, like if it has a high forward voltage drop, it'll only light up if it's being given 5 volts from the programmer. But wait, you might say, I have a genuine AVR ISP Mark II programmer from Atmel, and the Atmel programmers, they don't provide your board with voltage. They require your board to be already powered and to have voltage on that pin so that they can like check what voltage level it is and give it the right signal level. So if that is the case, and this is sort of a corner case, I don't expect that a lot of people will have these because they've been discontinued. But in that case, you can solder blob this jumper over and you can provide 5 volts on this pin. And then that will still be attached in programming mode. However, it is a little bit of a danger thing because this also needs to be, the battery needs to be turned to off. If it's turned to on and the battery's in here, then you're going to short your 3-volt battery with 5 volts, and that's not good. So only do that if you know what the fuck you're doing, is my thing. Otherwise, just use the USB ASP. It's a great programmer. It provides 5 volts, and you don't have to worry about any of that stuff because the switch will, when this is not soldered over, it will properly isolate the 5-volt power during programming as well. So I think that's like most of the explanation of this board. And then right there, we just have a pull up on the reset pin to keep it nice and high unless we really want to reset it. And then we have the decoupling capacitor, power decoupling capacitor. So that is pretty much it. So what I'm going to do now is I'm going to do a design roll check because we have not actually, I've not actually done that on this board. Oh, actually, I think I want to try to associate those pins to ground first. So let's see if I can do this. I'm just going to go to properties of this pin, net name, ground. How does that work? Hey, now it's connected to ground. Cool. The one thing that I wish KiCad did, and I need to look at the, like I'm using the last official stable version, which is 5 something. I'm seeing a lot of scuttlebutt online about version 6 and how it has a bunch of different, a bunch more capability in terms of selection. So like what I really want to be able to do is like just like chain select all of these, right? And then go to properties and adjust the properties, but you can see that properties is not a selection here now. So you can only edit things one at a time right now with KiCad. There are a couple things like, I don't know if this will work. So with pads in particular, there are ways of propagating changes. So hopefully I'm not going to screw anything up. I'm going to copy pad properties and then I'm going to save. And so when I keep this, I say copy pad properties, I keep this selected, I right click again and go to pads, push pad properties, and then it gives me some options. So basically, you know, I want to push this to these other pads on this component, and even if it pushes it to my other switch component that's the same, that's cool, that's fine. So there are a couple of options. They don't have like, oh, change pads on identical footprints. Look at that. So it's saying, so my options are don't modify pads having a different shape, correct. I don't want to like, you know, modify like all of my pads on the circuit board and make them all ground, right? That would be bad. Don't modify pads having different layers. True. I just want to modify my 2 components on the bottom. Don't modify pads having different orientation. This I think I want to uncheck because my other switch actually is rotated 180 degrees. So I do want to update that one. And now my options for making this go are change pads on the current footprint, which would definitely work, or change pads on identical footprints. So I'm going to try this one because I'm hoping that it will change it on the other switch that's on the opposite side of the board too. I don't know what just happened, but oh, it didn't. Oh, that sucks. Okay, this is why we save, and this is why we like undo. So that's interesting. It changed the pad shape of these, but it didn't do anything with the net association. So I'm guessing that pad properties is just physical properties of the pad and not net associations. So we will Control Z, undo that. I'm going to try one more time and see if there's a different setting. Copy pad properties, and then pads, push pad properties. I'm going to say do not modify pads having a different shape, and then change pads on identical footprints. No, that didn't work. Okay, well, let's see. Okay, one more time. All right, pads, copy pad properties. I wonder what happens if I just use the paste pad properties to here. And it didn't do anything. All right, so we're just going to have to go through this one by one. It's not the end of the world because there aren't that many pads, but it is sort of a lot of clicking. And you could imagine, like, if I had a whole bunch of switches on this board, you know, this would be super annoying. And like, yeah, I know that's when people are like, oh, I can just write a script to do it. But like, honestly, by the time I like wrote and implemented a script to do this, I could just change all of these stupid pads manually. So it's like, for doing something once, I am not going to go through the hassle of writing a script. And also, I've never done that in KiCad, so that would be a learning curve for me, which would take even more time. So not warranted on this board. And also, I hear that you can do some group selecting and stuff like that with the with version 6 that everybody's working on. And I think I will. This is probably the thing that will push me over the edge. Everybody says that the nightly builds on KiCad are like the way to go. And so I think I will start using the nightly builds. Even though like that, it makes my like production engineer heart cringe, right? Like, oh my God, you don't want to use a freaking production tool that's changing every day. That's crazy. But I think in this case, it is probably fine, you know? All right, so we've now associated all those with ground. I'm going to save. And now I'm just going to repour this pour. I haven't found like a super slick way of doing that. I just tend to go to properties and then click OK again. And then it kind of flashes to the 3D view, and then it repours the pour. And so now you can see that my ground pads are, or that my mounting pads are now connected to ground. They have the little spokes. They have more, you know, mounting relief there. They'll be sturdier. We like sturdy pads. So yeah, I'm happier with that now. Cool. All right. Did it change the other switch? Yeah, no. So I think you probably followed all of that, Deborah. But yeah, it did not. That the push pad properties just did not push the net information. It was just pushing physical pad properties, and not even in a way that I thought it should. So although I guess if all of these pads are in fact the same shape, just not the same orientation, then it was probably doing what it was supposed to be doing. But yeah, oh well. All right, so DRC, I've never run this before, so this will be a learning process. Saving, are we saved? We're saved. I like saving. Inspect, design rule checker. I like the little bug icon. I think that's cool. So there are more DRC settings elsewhere, which is a little weird. I'm used to being able to get to the DRC settings from the like run DRC console. I wish those weren't separated as much. They're a little separate on Altium too in places, and I think it's just annoying and kind of confusing. That's okay though. So the main checks that it's doing here are clearance controls. And so we're going to look at those. Minimum track width, 8 mils. Yeah, that's good. That covers you for like all kinds of like cheap, rapid PCB prototyping. If you push that down to 5 mils, you may or may not be able to get your board made cheaply. But it is very doable. Anything below that, though, is like, then you're talking really specialty traces and spaces. So let's see, minimum via size. It's talking about the actual like outer size of the via. I think 25 mils is what I'm using. Ooh, I do want to create a report file, maybe. I don't know. Do I? Let's see. KiCad, RGB. Yeah, we'll do that. Microvia, I'm not using microvias. Refill all zones before permitting design rule check. This is a good thing to do because this basically I'm used to calling them copper pores from Altium, but here they're called like zones, I guess. But it's basically, you know, your copper pores that are associated with the net. So you're like your ground pores, your power pores, that kind of thing. So that's good to do because while you're tweaking stuff, you might like move a trace around or make an adjustment and then forget to re-pour the copper. And so your clearances might be off, or you might accidentally like be shorting, you know, the copper pore to the trace that you've just moved. So re-pouring the copper pore before you run the design rule check will like make sure that you're in the current good state of the copper pore. Report all errors for tracks slower. Don't really know what that means, but we'll go with fast for right now. Test tracks against filled copper areas very slow. You know, I don't think I need to test all the tracks. If I've just refilled the copper pore, I feel pretty good about that. So we'll do it. Run DRC. Report file created, yay. Messages. It's not showing up in here. Unconnected items. So this is no surprise, right? This is our VBAT net, which is broken up into two separate things. So we know that that's a thing, and we're just going to ignore it. I'm like, what I'm not sure. I'm not sure if these messages are problems, are they warnings, or are they just like, oh, these are the things that we just checked? So I think I want to like look at this report file and see what's going on there. Oh, where are we? We are there. KiCad, RGB, and report. No, open it with Atom. Atom's just my text editor of preference. And let's see. Okay, so nope, that was it. The only DRC error that was found was the one that was reported, our unconnected net. So cool. So basically that means that all this stuff was just in the messages are just the things that it's checking. So that's cool. I kind of like, let's do all the slow stuff and see how slow it actually is. No, that was not very slow. And you know, it didn't come up with anything else. So yeah, I think yeah, the testing tracks against filled copper areas is just, you know, it has to check all of this surface area basically throughout the entire board, which is a lot. So but happily is pretty fast with a modern-ish computer. Cool. All right. So I think we're almost ready to send this to Fab. What I like to do two things. I like to take one more look at the 3D model to see if anything pops out to me that that like I think should be different. Oh, one thing you will notice with this 3D model, and so this is going to be something for, this is going to be something interesting for like exporting gerbers, and I'll be interested to see how the direct upload to OshPark handles this. So there's a global setting, and this is also part of the design rules, board setup. So board setup is where most of your design rules are. So there's a section design rules here, and then this has more stuff that you can do. So this is like main things, which was pretty much repeated in that little dialog box about the track width and the via diameter and stuff like that. Then you can set up rules for different net classes. So I have a power net class, which is basically VBAT, VPROS, and VCC. And I wanted the default track width to be 20 mils for that, just because I like my power traces to be a little bigger. Not that they need to be on this board because it's like relatively low current, but it helps me also just differentiate the power traces from the other traces visually. And I just kind of like that. I like to keep my power routing as clean as I can. However, ground is still at 8 mils because ground tends to be more interconnected because I do ground pours for everything. So I know that there's going to be a lot of ground surface area and connection area, and I'm almost never worried about like low impedance grounds. And then default tracks, track width 8 mils, clearance 7 mils. It's pretty standard. 8 mil clearance is like fine too. So you can do different stuff for tracks and vias. Solder mask and paste. These were all defaulted to 0. And yeah, I kind of disagree with this. Yeah, I don't know how I feel about this, actually. I would love to chat with more people on this subject. I'm used to having a very small solder mask clearance and a negative paste clearance on my boards. And basically, this means that the solder mask clearance is the distance between the edge of your pad and the beginning of the solder mask. So it's basically the gap between your pad and where the solder mask starts. I like there to be a small gap there because if I put that at 0, then the solder mask is never perfectly registered over your circuit board. It's like it's a different process. The registration isn't perfect. It's always going to be a few mils off, especially for like getting stuff made like cheaply. So I don't want there to be solder mask that's overlapping my pads. That'll make it harder to solder to. It might make it flow kind of weird, whatever. Same thing with paste. I don't want the paste to go all the way to the edge of the pad. I want there to be a little bit of like paste. I want there to be like a little bit of gap between the end of the paste and the end of the pad. I want the paste to be like a slightly smaller area within the pad. Because I feel like that controls it more. It prevents it from going places it shouldn't. And it prevents there from being kind of like too much paste on a pad, which is a thing that when you're hand assembling boards, when you're hand stenciling, which is what we'll be doing for this board, that's a concern, because it is when you're hand stenciling, you're always going to get like more solder paste than is optimal. It's very difficult to get like, just enough, especially on teeny tiny pads. So that's why I like putting clearances in there. KiCad is telling you to set solder mask minimum width and solder mask clearance to 0. I agree with the minimum width is 0. That's basically a control for like if you have a really fine pitch component with a lot of little small legs, that sets a minimum for the amount of solder mask that can like be in between those legs. And I don't find that as super useful. So I let the board house basically set that and keep that to 0. But I don't necessarily like agree with the solder mask clearance thing. But the problem is KiCad does not allow me to set, at least in this dialog, it doesn't allow me to set a different clearance for pads and for vias. And I think that that's totally stupid. So what is happening here, I'm just going to get out of here, is when you see it on the 3D viewer, see how you see like a little ring in the middle of all of my vias? I don't want that to be there. That's that solder mask clearance. It's backing off of my vias, and I don't want that to happen. I want my vias to be completely covered by solder mask, which is also called tented. So I want my vias to be completely tented. And I think that there might be an option in Gerber generation to completely tent your vias. Gerbers are the format for circuit board CAD files. So I think that there's a Gerber setting for that. But if I'm uploading to OshPark allows you to just like upload native KiCad files. So if I upload the native KiCad file, I don't know if that ring is going to be there or not. I have a feeling it might be. So I don't know. I might actually want to upload Gerbers for this, or I might want to just put that setting at 0, even though it bugs me. So yeah, decisions. Not quite sure what to do there. I think I'll just try uploading it and we'll find out. Okay, so let's see. But I do, so even though I don't necessarily have to generate Gerbers because OshPark will, will take native files, I do like to go through that step of generating them and viewing them because you can build them up in layers, and it's another slightly different visual means of checking out your circuit board, essentially, that you might catch things there that you have not necessarily caught on the layout or in the 3D view. Although I do find that the 3D view now takes a lot of that, takes a lot of the visualization that I was previously doing with Gerbers. Like, it takes the place of a lot of that. But I still think it's, helpful because you might have like, I don't know, a via underneath a component that's like not tented and it should be or something. It's also a little weird that I can't set a via style that is like tented so that I could just like make all of them tented. Those are definitely like, they're very, I will say that Altium has like very granular settings when it comes to properties, when it comes to DRC checking. It really allows you to fine tune your circuit board and to really set it up the way that you want that's appropriate for that board. Whereas KiCad, a little more limited. However, not limited enough to justify paying $10,000. That's for sure. All right. So we're going to go to plot. Plot is how you make Gerbers. So output directory, we're going to put it in our VG directory. I think I'm going to make a new folder here. I don't know if it automatically does that. RBG, RGB, Gerbers. Okay. Do I want to use a path relative? Yes, I think so. Okay. All right. So let's see. Plot, border, and title log. Oh, I have not set up a Fab Notes file, which is another thing you can do. Again, if you're doing a completely online quoting system, maybe not necessary anymore because you're already putting like adjusting settings for how thick the circuit board's going to be, what colors you want, blah, blah, blah. Of course, with OshPark, you don't really get a choice. You get purple. But that might be something that I would do. That would definitely be something I would do to get like production quantities of these boards made because I want them to be in black and, OshPark, well, they do the After Dark, but this one is not an After Dark board. There's too much craziness going on with the artwork. I mean, I think it would look great as an After Dark board, but I'm not up for that. I've spent too much time with it already. So the border and the title block would be something that I would do to create a Fab Notes layer. Plot, footprint, values, and references. Yeah, they're hidden right now, so I don't think that those matter. But that's interesting that you can choose independent of whether or not they're viewable in your circuit board layout, you can choose whether or not to export them. That's cool. Oh, force plotting of invisible stuff. Yeah, we don't want to do that. Exclude PCB edge layer. Yes. You generally do not want to include your board outline in your gerbers because, you know, your gerbers are what you're actually is like the copper or the silk screen, the stuff that is actually going to be on your board. And so you generally just want your like outline layer to be, your board outline layer to be just on its own and not with your other layers. Exclude pads from silk screen. Oh, do not plot pads on silk screen layers even when they are assigned to them. That's interesting. We don't have any pads on silk screen layers. Oh, interesting. Do not tent vias. So default is to tent vias. So that's good. That is what we want. So let's see, blah, 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 generate Gerber job file, sure, subtract. Oh, interesting. Subtract solder mask from silk screen. So this is something, yeah, actually, that's something that I should have gone over with the eyes. Basically, if you have silk screen that is overlapping an area that is free of solder mask, it's pretty much a board house default to just chop the silk screen in that area. Why? Why don't you want silk screen over a place that's like free of solder mask? It's generally because places that are free of solder mask are usually pads. They're usually things that you want to solder to. And that was, you know, that was one of those things that you used to have to manually check for before DRCs got really good, is that you had to make sure that you did not place like a reference designator or a silk screen outline or whatever over a pad, because like that would actually then be printed on the pad, and then you'd have this epoxy silk screen on your pad. You wouldn't be able to solder to your pad. It was like a, you know, big hassle. So, but pretty much now automatically board houses will automatically subtract any silk screen that is overlapping a zone that's free of solder mask. But I had to keep that in mind when doing the stuff with the eyes, because I had the silk screen layer first, and then I was creating stuff around it. So I had to make sure that the keep out zone of copper and that the solder mask, the keep out zone for the solder mask, did not overlap the silk screen, because I wanted the silk screen to be printed for her eyes as well, again, to give them like a little bit more shape and life. So yeah, that was something that I was attentive of. Okay, so what layers do we have? We have top and bottom copper, top and bottom paste, top and bottom silk, top and bottom mask, and edge cuts, which is our board outline. I think that's good. The formats, you don't have to worry about it too much. Oh, unit millimeters, interesting. Oh, okay. 4.6 means like 4 things before a decimal, 6 places after a decimal. 6 places after a decimal is like so overkill. It's crazy, but whatever. I mean, it's not really gonna matter for this board at all. All right, and then generate drill files is a separate thing. Interesting. Okay, so we will plot. Bloop, bloop, bloop. I think we did that. Created job, cool. It's in there, excellent. I'm also going to generate drill files. So we have some more settings here. Drilling is a different process. It takes a little bit of a different file format than the gerbers, which are sort of this photoresist etching process. So drill output files are more like CNC, you know, based. I am going to use, let's see, Epsilon drills, origin, decimal format. What's nice here is that you can get a count of holes, and that is kind of helpful because especially this non-plated pads one, there have been times when I've created a new component and it's supposed to be a through hole component, and I've forgotten to check the box that's like, plate this pad through. And this is generally the place where I catch it, because I look at my non-plated pads and I'm like, huh, why do I have all these non-plated pads on my board? Like, that's not right. And then I realize it's because I messed up in the in the component creation, and then I can go back and change it, and then they show up as plated pads instead of non-plated pads. Here, we do legitimately have non-plated pads. We have these holes right here. Non-plated pads are just essentially holes, just, you know, and we have 2 per switch, and they're for locating pegs that the switch has in like coming off of the bottom of it. And that helps it stay in the right position and also not move while soldering, while reflowing. So those are good. We have 42 vias. Cool. All right, we'll generate drill file. A map file is just like a visual output for where all of your drill locations are. That is less helpful for me, so I'm not going to do that. Close, close. All right. Neat. So I thought now that KiCad had a Gerber viewer built into it so that we could, view Gerber files. Excellent. Oh, yes, we always want to enable acceleration. All right. Because my fan isn't going enough on my little laptop right now. I only have like 20 tabs open too, and video streaming, you know. So let's see, we're gonna open the job file, because that will probably include everything, right? Maybe, I don't know. Hey, there we go, cool. So here we go. Here's everything that we plotted. Of course, like, it doesn't take the same default colors that you're using in your PCB. So now everything is looking different because all the layers have different colors, but that's okay. All right, now we're going to see about how this looks in order to kind of like get an idea of this. So we're going to hide all of the layers right now and make this a little bit bigger for you. So I'm thinking about now, how is this board constructed? Well, you know, I have my top layer. Let's enable that. Okay, so that's my copper layer. And then I have my solder mask layer. So now I'm seeing the solder mask layer on top of that, and everything is pretty much where I expect it to be. There are little solder mask openings, it looks like, for these mounting holes, which is fine. And then, can I make this bigger? Oh, I don't like how KiCad zooms. It's kind of different from what I'm used to. Okay, and then so that's our solder mask layer. And now, and also I can verify now that these vias are in fact tinted. There have been no blue solder mask, you know, round pads over any of these vias. I can zoom into to make sure that I'm not getting that little ring. I'm not getting that little ring. Cool. So so that has like verified that the tinting is working as I think it should be working. So now I'm going to enable the silk layer, and I'm going to kind of make sure that it's not, like, as it overlays, I kind of do this visual check to make sure it's not overlapping any of those solder mask areas, which, you know, we could have done the cutout too. But so you can see here what I was talking about with the eyes. So when I enable it, here, I'm going to zoom in so you can really, really see. So you can see that this blue shape is over the copper, which is the purple. And now when I enable the silk screen, you'll see that the silk screen is like kind of like right up against it here. So if I had been sloppy about the creation of this shape, and if I had made it like a lot bigger and, let's say, continued the roundiness here, even if I generated a Gerber that showed them overlapping, it is very likely that the board house would just cut this part of the silk screen out. And, you know, basically the default is cutting the silk screen to match the solder mask, not vice versa. So if I had left that solder mask shape bigger like this, I would probably get like no silk screen there, and then her eye would be a weird shape, and it wouldn't look like any of the previews that we have been looking at. So yeah, all sorts of like small details on this board too to get it all working out right. So I think that this is pretty good. Like this looks like I think it should. You know, the vias are covered except for those two, which, you know, we don't even see right now because they're tinted and everything. In reality, we'll like kind of see like a little bit of a bump there. But that's good. So oh, and then paste. So we should see nothing on this layer because there are no components. Yep, nothing. Cool. So now I'm going to hide everything again. And we're going to do the same for the bottom layer. And hopefully their layer stack up is appropriate for this, for doing it the same way. So we have the bottom layer. Cool. And now over top of the bottom layer, we have the mask. It's not quite doing it. That's annoying. So, okay. So if I enable that layer, yeah, default behavior, I feel like should enable you to stack it should enable you to stack the bottom layer like you're looking at it flipped, not like through the board. But anyway, whatever. Now, so that looks pretty good, and we'll just unenable that and then do that again. So now we can just like verify that all of our, you know, all of our pads that are surface mount components are free, our vias are tinted, you know, we have a really clear indication that everything is looking like it should be, right? And then we have silk over top, over top. Yeah, the stack sucks. Like the layer order is dumb for this, and Altium recently changed their Gerber viewer to be like this, and I was just like, are you kidding me? You just took something that was working well for 10 years and made it worse. Really, you should be able to do the same kind of layer stack up that I did on the top, because that gives you information about what is overlapping and what is not. And right here, it's, you know, it's hard for me to see that because now the solder mask layer that's that you know, greenish color is now below the bottom layer, which it shouldn't be. But that's all right. Maybe we'll just disable this. We'll enable that. And now we'll see about the paste layer, because this is also important. Yeah, and it's hidden. So we just want to make sure that the pads, we want to make sure that our pads that that we want to be paste-free are paste-free. So like the battery pad, we don't want paste on it because we want it to be a nice smooth surface for the battery to slide in and make contact with. We don't want there to be any paste on this jumper because we don't want it to accidentally be closed. We don't want any paste on this because this will be hand soldered. Same with here. So now we've verified all of that. And so yeah, last thing is just verify the board outline. Yep, that looks good. Cool. So yeah, this Gerbers are looking good. I would be confident in sending these to Fab for sure. So, all right, cool. Now, let's save again. Let's upload this to OshPark and see how it goes. Woo! So I will open OshPark in my browser, and then I'll pull it over to my screen here. Let's see, logging in. Awesome. Okay. Yay, OshPark. So we're going to browse for files. And I don't know if it matters if my file's open or not for uploading. We'll find out. So now, let's see. We'll just go to that one. Navigate here to my board. So I can drag and drop my KiCad, Eagle, or zipped Gerber files. So I'm just going to drag and drop the PCB, and we're going to see what happens. Well, that's happening. I think I might create a zip folder for here. I forget the default 7-zip thing, so I'm just going to do Windows. Blank. Cool. Okay. Description. RPG with a crown and rainbow eyes. Cool. Redrawing my fill zones. Note blank layer top paste.ger. Yep, we know that we don't have any surface mount components on the top layer, so that should be free. So it isn't. So it's showing my holes here. I'm like hoping that those won't be visible with the actual circuit board because those holes are so small. I'm hoping that the solder mask will go right over them and that the silk screen will go right over them and that her face will be smooth. So we'll see if that is in fact the case. So let's see. So it looks like, so everything is looking like I think it should, right? And so I'm zooming in here and I'm not seeing those rings around the vias, which is good. So it does seem like the KiCad processing included tenting over all of the vias, which I'm very happy about. That is as it should be. I am seeing like a little bit of a ring there. There might, like it might be sometimes mounting holes. I did not create this pattern. Sometimes you end up with like a little artifact there on your mounting holes, and typically it does not make a difference. That is because if your hole size is the same size as your pad size, right, then it's sort of thinking that there's like a little bit of copper there essentially surrounding your hole. But it's not plated through, so you know that should be fine too. Yeah, this is looking good. This is looking like we want it to be, right? I got my logo on there. Woo. All right. So let's go back to here. Drills are looking good. That is definitely where my holes should be. Top layer looking good. Bottom solder mask. Top solder mask. Yep, top silk screen looking good. Bottom layer looking good. Bottom silk looking good. And board outline. Cool. Well, I think that this worked pretty well. So like didn't have to make gerbers, but I feel like it is helpful. I'll have to play around. I'll have to see if I can rearrange the default drawing order of the gerbers, because if you can, and if it's persistent and you don't have to redo it every single time, then it is I feel helpful in seeing that layer by layer stack up. Because you sort of can do the same thing in PCB, but not quite, because you have through-hole components that are sort of multi-layer, and it just doesn't give you that same visual of like board, mask, silk, paste. I have caught errors there before, so that's why I like to do it. All right, anyway, order. This is so exciting. Live, streaming, ordering circuit boards. Ha! Order, hello, click. There we go. Okay, so we want to order 3. That sounds good. And we're gonna go for super swift service. Use because I would like them in like a week. I can't believe it's only 40. Oh wait, no, that's not the board. That's something else that I have in my cart. Ah, that's an ISP header. I was gonna say that's super cheap. Okay, so that must be from a different thing. I thought that yeah, I'm gonna remove this from cart. I don't think I need that one because I have a ton of the ISP breadboard adapters. I think that was a remnant. I just got a bunch of those in. Okay, so there we go. The 18 sounds like more reasonable. I was like, sounds really cheap even for Hodge Park. So yeah, and I'm still going to go with the Super Swift because I want to get them in 427 calendar days rather than twice that time, because I want to check them out. I want to assemble them, check them out, make sure that nothing's wrong with them. And I'm going to check out. And at this point in time, I think I'm going to go on the screen that I'm not sharing. Not that I think that any credit card information is identifiable, but oh, okay. There. I will do priority mail shipping. complete. So one thing too, which I'll put back here if it gives me the option, which I think it will. So I'm going to go ahead and pay for the order now. Card payment, use existing card. Yep. I have all my information. Got to make this easy. Cool. Aha. Now back to sharing. Haha. Check out our partner services below. I'm so happy that this is a thing now. So I've also been using Osh stencils for a very long time, and it's been very exciting to see them grow as well. And yeah, man, they make a great service. So, and it's awesome now that I can proceed directly to Osh Stencils from Osh Park and order a stencil. I am not going to be making like a ton of these. Oh, hang on, I'm just going to do this because I have no idea what my shit is. Password manager. Yay. Okay, cool. So now it's directly importing my project from Osh Park, which is fantastic. And so yeah, I am not going to assemble these myself in any quantity. But for this board, which has so many like kind of small surface mount components, like, yeah, I will reflow this using my like tiny little reflow oven and do a stencil for it, because it'll just be way easier than hand soldering it, even, you know, just for 3 boards. So, so yeah, why not get a stencil? And it's also just nice to have practice too. Okay, so we want the bottom stencil for sure. Bottom stencil update. None set, that's fine. We're going to delete the top because we don't have a top. Bottom stencil. Don't know if we need a board outline file or not, but that's okay. So, all right. And, oh, new project name, RBG, RGB. Do I have to create project or launch? I don't know. Generate stencils. a lot of stencils in my past. So let's see. Okay. So we have bottom stencil. Cool, that pretty much looks like the bottom to me. So material type, I always want to do the stainless steel. Interesting. So the frameless is what I usually do, and 3 mil thickness or 4 mil thickness. Yeah, I usually do the recommended thing. So let's see. So we'll add the stencil to the cart because that'll. Oh, and we can also do. I actually do like to do the engraved text. So I will do like. I will always do like the board name, because you're just like, oh, what freaking board does the stencil go to, right? So sometimes I do our name, Alpha Industries, and then I'll do like RBG, RGB. And do I need to do anything else? I don't think so. So this is, so now you can see that that will actually be etched there. And I'll actually put PCB there just to have it be complete. All right. Border size 1.25. Like, I feel like a smaller border is actually a little bit handier. So I'm going to make just the border size like 1 inch. Maybe. Can I do that? Maybe I can't do that. The value in this field is invalid. Okay, well then we'll make it 1.25 then. There might just be like a minimum size that stencils need to be. Okay, so now we're going to add the stencil to the cart. I'm also kind of interested. I think it's going to kind of be more than I want to spend for this board, but I am interested in knowing what it would be for the 14 by 14 slim frame, because I do actually have a frame holder for stencils that has like little movable bed and stuff. And man, is that cool when you're doing a bunch of stuff. Again, not totally necessary for this board because we're just getting 3. But you know, if it's not too much more, might do that because it's just nicer and easier to align. So let's look at the cart now. And oh, interesting. That's weird. Yeah, so we got like $150 for the framed one versus like $20. So yeah, I think I'll go for the $20. And interesting, I got like 2 in my cart. That definitely has my text on it. So does that. I'm confused. Oh, engraved line, RGB, PCB. Interesting. Okay, so I'm going to remove this one. And because this one had the engraved lines on it. Okay. Did it just increase in price? Weird. Okay, whatever. Cool. Woo! Cool. So we are all good. Yay! So we've ordered boards. We have, yeah, it's all good. Of course, this is the time when I'm going to notice a mistake. So I'm going to close this. That's what I'm going to do. So anyway, I hope that this has been a good stream for you. And yeah, hope that you learned sort of a little bit about how I go about checking boards. You know, even after you're entirely done routing, there's always more of the process of doing those final checks. A lot of times you'll see something you missed, like, you know, attaching those switch pads to ground. That was a good one. And so there's definitely like a little bit more iteration that happens during that final, like getting your board ready for fab sort of thing. And yes, we're probably not going to be doing our normal Wednesday live streaming this week because I've been doing so much of this board and I'm a little bit behind on stuff. So, but we will definitely come back at you the following week on, I think, the 29th. So yeah, and until then, like, you know, we'll be on Twitter if you have any questions about this. Twitter, YouTube comments down below. Make sure to subscribe. And also, if you want to be notified, if you want to actually get notifications about when we're going live and stuff like that, make sure that your subscriptions for our channel are set to all notifications. The medium one of like just custom or some or whatever, it like, I don't know what notifications those include, but I don't think it includes any sort of emails or anything when we're going live. So awesome. Well, great. Thanks so much for joining. Bye.